Hello students, since many of you were not able to attend my lecture on Wednesday, here is a quick recap of how to analyze a beam on STAAD Pro. So first of all, you open your STAAD Pro and when you have created a new drawing, a new file, this screen will appear. So let us take a look on the question. This is a simple beam of span 6 meter and it has a UDL of 4 kN per meter all throughout the beam and a concentrated load of 6 kN at a distance of 2 meter from the fixed end. The depth of the beam is 450 millimeters, sorry, and the width of the beam is 230 mm. So let's start with the geometry of the beam. First of all, we will define the nodes in which we have to join the beam. So since this is a case of single beam, we will create two nodes, one with x0 and the other with x equal to 6, y0 and z0. So you'll see that a beam has been created on the x-axis. Two nodes have been made on the x-axis. Now we will join these two nodes and to make a beam. So in this node dialog box right here, type 1 on node A, 2 on node B, and we have joined the beam. This is a geometry part. Now we will define the properties of the beam. Define. This is a rectangular beam with depth equal to 0.45 meters and width is equal to 0.23 meters. Material is concrete, add. So after defining the section properties, we have to assign it to the beam also. So right here, now we will click use cursor to assign, click on assign and then click on the beam. So the R1 right here denotes that this beam has been assigned a property. Close this. Next we go to materials. This beam is a reinforced concrete beam. Click on concrete. Assign to selected beams. Assign. Yes. Concrete has been assigned. The material part has been complete. If you want to change the properties of the concrete, like change the grade of concrete, you will click edit here and change its properties. You can also create a new property. Type in the Young's modulus, the Poisson ratio, etc. here. Give it a title and then assign it to the beam. Close. So after material, here we don't have any kind of specifications. Now we come to the support part. So as we can see in the question, there are two types of support. One is the fixed support and the other is the hinge support. I'm sorry, we don't read the roller right now. It's a normal hinge support. A simple, basic example. So we need to define two kind of supports. Create. One is fixed, add. Again create. Hinged is also known as pinned. As you can see that fx, fy, fz, that is movement is restrained, but it's free to rotate. That's why the moment is free, is not restrained. Add. So again the supports have been created but not assigned. Now we will assign the support. Support 2 is a fixed support. Click on the support. It will become highlighted. Use cursor to assign. Click on assign and here. Now click on the hinged support. Use cursor to assign. It's already assigning. Click here. close the assigning part, click on close, and hence the supports are defined. Now next is loading. This needs to be seen very carefully. The load case details, we have let me delete it and start it again. Yeah, so this is how it will be on your screen. Click on load case details, click on add. First we'll add dead load. Like this, add, and let's keep it to dead load only. We'll discuss about live load later. Dead load, alright. Now click on dead load, select the dead load part, again click on add. So first of all, the question here does not specify that we need to add the self weight of the beam also, but if it does, what we'll do is just give a factor of 1 or 1.5 times the self weight of the beam. The self weight will be calculated automatically depending, like we have given the length and the dimensions of the beam, the dimension of the cross section of the beam, and we also have given which kind of material it is, so the self weight will be calculated automatically. We just need to define the factor. But here, since the question does not ask for it, we will not define the factor, and we move on to member load. So we have a UDL, a 4 kilonewton per meter, and now see very carefully how to do this part. A minus sign to show that it will be applied in the negative y direction, that is downwards. Type 6. Now we have to define D1, D2 and D3. See, D1 is at how much distance from the end the load starts to be applied. So since the UDL is being applied from the start, this will remain 0. D2 is from this point, from the start, till which point the UDL is being applied. So it will be 6 as the UDL is applied throughout. The D3 is the eccentricity from the center of the beam, and this will also be 0. Click on add, and we have added the UDL. You can see it here. Next we have is a point load of 6 kilonewton. My bad, the UDL was of 4 kilonewton per meter. Just a second. Yeah, we can edit it from here also. It was of 4 kilonewton per meter. My bad. Modify, close. So it's done. Again click on dead load, click on add. Now we'll go to member load. Concentrated force, it was 6 kilonewton, so again a minus sign, then type 6, and it's done. D1 is at what distance from the end? It will be 2 meters as specified in the question. So 2. D2 is eccentricity, that will remain 0. Direction will be global y. Add and close this part. So now we have defined the loads, but we still need to assign it to this beam. Click on the load, click on use cursor to assign, click on assign, and click on this beam. The UDL has been assigned. Click on the concentrated load, it's already assigning. Again click on the beam, so it's assigned. Again click on assigning to stop assigning, and when you click on dead load here, so yeah, you can see that the load has been assigned. This was the loading part. Close this, go to analysis, click on define commands, perform analysis, all kinds of analysis, add, and close. You will see that the perform analysis print all command has been added here. Click on close, and now we click on run analysis. Save this. Yeah, zero errors, zero warning, zero notes. So this is ready to run. Till last class we have done till here. In the last class we have done till here. We have stopped here. Now we shall move forward to check how to see the results of the analysis. So we have to go to post processing mode. Either you can click here, go to post processing mode and click done, or else I will show you another thing. Stay in modeling mode, click on done. When you double click on this, you will see that this gives the value of the shear bending and the deflection. But to check the results in a proper manner, in the workflow panel, click on post processing. The dead load is already selected. Click on OK, and these are the results. We will view it from this angle. That's the YZ plane. We will view the XY plane. Sorry. Again, go to results. So no displacement or deflection. Click on reactions, and it will give you the reactions, the X, the Y, the Z reaction. Similarly, click on beam results. This is basically the bending moment diagram. See, you have clicked here, you have clicked MZ here, so it's showing you the bending moment throughout the beam. As you can see here also, these are also the results. Click on FY. This is the shear force diagram, and Fx will be 0 because there was no force in the other direction. So this is the result part, and this much is required for the assignment given to you this week. Another thing which I would want to tell you is that when you click here at reactions, you'll see that MZ and here is in kip inches, and like the moment is in kip inches and the force is in kilonewton. So how to check, how to set this right? Right click in this area, go to display options, click on structure units, and here you can set this right. Set everything to kilonewton per meter. Set the moment to kilonewton meter, and you can see here. So this way you can change the force units in STAAD. Next part is generating reports. So you can click on the reports tab here, and we will add everything in the report. So click on this double arrow and click on OK. So this is the report that has been generated. So thank you guys. This is a basic tutorial of how to analyze a beam, and just a startup on how to use STAAD and a gist on what it can do. Thank you very much.